안녕하세요, I'm David, and today I'm going to do the special assignment assigned by Mr. Alvin. So the question that I have been assigned to is the question 8 of subjective questions in the fall 2016 midterm test. Okay, so here's the question. Okay, and the question is: a 15 feet ladder is leaning against a wall in a garden when its base starts to slide away. By the time the base is 10 feet from the wall, the base is moving at a rate of 6 feet per second. So how fast is the top of the ladder sliding down the wall? So when we are doing math and we can sketch a graph, then we sketch because we don't want to confuse ourselves. So firstly, I'll sketch the wall that is in the garden, and then I'll put a base over there. And then I'll put a ladder. So this ladder would be 15 feet. Okay, so I will put here as y, here as x, and then in a question, it shows that by the time the base is 10 feet, 10 feet from the wall, the base is moving at a rate of 6 feet per second. So they actually showed us like one of the things that we need in the problem solving. So what we get is dx dt, which is 6. So what are we going to do here is we could actually use chain rule to solve this problem, because like we need to solve the problem how fast is the top of the ladder sliding down the wall, and then means that we need to find dy dt, which could be chained by using dy dx times dx dt. So since we already have this one, what we need to find is only this one. So we could use this one times this one to get this one. Okay, so now we'll start off with dy dx. So how are we supposed to find dy dx over here? So since we have chain rule over here, there's another thing that we need to use in order to figure out the equation over here, which we would call it Pythagoras theorem. It's actually in it's in math, like basic math, a part of basic math. It's actually about, let me draw it out. So this is a triangle and 90-degree over here, right triangle. So C A B. So this is Pythagoras theorem. So it's actually a square plus b square equals to c square. So back to this question, what we can use is over here, here, and here. So all the proper workings would be black in black color. So now we could use x square plus y square equals to 15 square. Okay, so since we need an equation for the differentiation, to find dy dx, leave y on the left side and then throw x squared to the right side, become negative x squared, and then we will get this equation, and then modify a bit so it would be easier for us to differentiate. So it would become in this form. Okay, so now we got this. Okay, so let's do our differentiation. So dy dx would equals to 1 over 2, and then you write back what's inside the bracket, which is 15 square minus x square, and then 1 over 2 minus 1 equals to negative 1 over 2, and then we have to times what's inside the bracket, which is 15 square minus 2 square, x square, and then we will get negative 2x. Okay, so do you guys still remember that we have the x equals to 10 over here? So now we are going to substitute x equals to 10 into the equation. So we are going to get 1 over 2, 15 square minus 10 square. Okay, negative. Okay, shit. It's okay. Okay, so here should be -2 and then 10. So what are we going to get is, okay, you can just simply use the calculator, and then the answer that you are going to get is, wait a second, okay, you are going to get -0.8944. Okay, so now we have our dy dx. So because of dy dt equals to dy dx times dx dt, so now we have both. So now we have found our dy dx and this one, which is 6. So we could straight away substitute in. So dy dt equals to -0.8944 times 6, so equals to -5.3664. So okay, now we have to modulus it, because this one is actually negative velocity, yeah. So in order to fulfill the question's requirement, which is how fast is the top of a ladder sliding down the wall, we must change it into speed. So that's why we have to modulus it. So we put modulus over here, it would become 5.3664 feet per second. So that's all. Okay, so thanks for watching this video. I hope you guys enjoyed this video, and do leave a comment if you guys have any questions to ask. Okay, and so I hope everyone can do well in their finals exam for calculus. So enjoy and happy Thursday. Thank you.